Hi guys. I hope you can all hear me. Yeah, this is my very first stream, and yeah, I never did something like that before in public. So let's see how this works. I'm pretty excited, but I think yeah. I'm going to show some AV Evasion 101 today, and the topic is especially PowerShell today. So I'm going to show the basic techniques, methods to execute basically any PowerShell script you want without being detected, or by bypassing the protection mechanisms that are established there for PowerShell. So yeah, I prepared a little content before, so I have don't know the right word, but I prepared it, and yeah, now planning to show at first the protection mechanisms that are active here, and I'll tell you a little bit about the history, at least my history and the history from pen testing and from AV evasion in general, and then I'm going to show you the countermeasures, how to bypass them, and yeah, that's basically it for today for PowerShell. Yeah, before I'm doing that, I have to say, when I began pen testing, Powersploit was the main thing, or the thing that caught my interest first, because I was able to go to the customers and I was able to show them here I can load basically anything directly into memory in the PowerShell, and there was no possibility at this point to either detect the scripts or to block them. And yeah, this was a pretty great time. There was no anti-malware scan interface at that time, and maybe that's why my enthusiasm for PowerShell is that big, and it's still that big. I still like to use it, and I will show you why it's still so usable here, and why we can still use it today, even in a time of EDR systems and better protection mechanisms. Yeah, so I did take a look yesterday. I did take a look at the very first Powersploit commit, just to see the timeline, and it's already 9 years old. So the very first commit was in 2012, and if you take a look at this one and look at the last one, here are many categories, many different scripts, and in the very beginning, it was one encryption script, one shellcode loader, and one DLL injection script. So there was pretty like nothing. And I think this is a good example that even the great repositories and even the great things started very small. And yeah, 2012, and I started with penetration testing in around about 2016. So it was 4 years old at that time and had many categories at that point. And PowerShell Empire was also released in 2015. This is the 2015 version from Empire, and it was pretty small at that time. But in 2016, 2017, I went to the customers and I was able to connect any client to Empire, and it was not detected. There was no anti-malware scan interface. It was pretty easy, and was the easiest way to do lateral movement in the environment. And yeah, this was really awesome, and it still is really awesome because it's still possible to execute all these scripts and to use Empire. BC Security is doing a really good job in updating Empire and in improving it. So it's still very usable and good, even nowadays. Yeah, but then because of the rise of PowerShell, the AV vendors and especially Microsoft introduced new protection mechanisms. And the first one and the most obvious one, and I think all of you already know it or at least faced it sometime, is the anti-malware scan interface. And one example, or the basic example, which shows that it's active, is you can type, for example, AMSI scan buffer or AMSI utils. These are strings that are blocked by the anti-malware scan interface, and you see that the script contains malicious content, has been blocked by the antivirus software. Basically, to explain this, the command was never executed at all, but it was analyzed before execution, and there's a signature database from Microsoft in this situation. If you have another AV vendor, they will have their own signature database for AMSI. In this case, it's the Microsoft database with the signatures, and things like Invoke-Mimikatz, for example, are or were not usable anymore. They are usable, you will see, but they are blocked if you directly try to download them. And that's done by signatures. So we can just try to, or one example to show that this is also blocked. I'm going to take hope I can find it that fast. Filtration, C#, PowerShell, credentials. No, that's the Python. Shell, external, filtration, Python, external. It's not the server side. Common. I don't know, but I'm faster to search it in my own repository. Yeah, that's I have this repository more or less to have all the scripts I'm using in one central place, and to not search GitHub and all other repositories for the things I use in my daily time. So this repository it's really a mess because I didn't document anything, and I don't plan to document it, at least not in the next time, because I think this will take really a lot of time. But this is basically what I'm using all the time, everywhere, and that's my central place for everything. So we can arm a new object. So basically this is what you do if you want to download a script from the internet, in this case from GitHub, from my repository. If you want to load Mimikatz or invoke Mimikatz directly into memory, it will look like this. But we can verify that the download works. If we do, for example, write the content into, oh no, we cannot do this because the invoke Mimikatz itself is blocked. Yeah, that's pretty stupid from me. But yeah, okay, we cannot download invoke Mimikatz, but we can download something else. Let's see. AMSI. This will not be blocked, I think so. Yeah, this works. So we have the content of the script in our variable now here, and it was downloaded. But if we try to load the script with Invoke-Expression or IEX, which is the shortcut for Invoke-Expression, the funny thing is this is even not detected by AMSI. So it's a script from Marius B. mgeeky. So his AMSI bypass is actually not blocked by Microsoft at this time of this stream. Disable AMSI. Let's see. Yeah, it was not planned to use this, but AMSI init failed. It should directly work. So it's still blocked. Don't know how the function names are here in this case, but yeah, you saw that AMSI is active here, and yeah, there was or I prepared all the methods for AMSI bypass in one repository, because I read many blog posts on how to bypass AMSI. I did not find a single one of these by myself, so all credit goes to the other ones that I mentioned here. But at least I put all those techniques to a central place to look them up, and yeah, we can just try to execute one of these bypass methods. The first one here, which is from Rastermaus, and try to bypass AMSI. This bypass basically takes the AMSI library, AMSI DLL, which is loaded into the PowerShell process. Maybe we can also show this here. If we take a look at the process, the PowerShell process, we will see that there are many DLLs loaded. Token fetch, performance statistics. Man, better preparation from myself. AMSI. Yeah, you can see AMSI DLL is loaded in this process, and this AMSI DLL analyzes everything that is executed in the console. And if you try to execute anything or to load anything, then the content is analyzed before execution. And if it's malicious, if it's something that's in the signature database, yeah, I'm going to show AMSI file a little bit later as well. But here, so we patched a specific function, namely the function AMSI scan buffer, in memory, because it's AMSI DLL is loaded in the userland. So everything that is loaded in userland can be easily modified by ourselves, because we can write into our own processes. We have the right, we have the permission to write into our own process, so we can manipulate the AMSI DLL in memory and patch, in this case, the AMSI scan buffer function to return either an error, so that it returns this is clean, or we can return a clean. So the result, the scan is done here as well. AMSI scan buffer was analyzed, but we patched AMSI DLL so that the return value is clean instead of malicious. And so because it's clean, it's now telling us that AMSI scan buffer is not recognized. Instead of it contains malicious content and has been blocked. So we actually bypassed AMSI in this case with the very first bypass, even without modifying this. This is because I executed it line by line. normally all those bypass methods that are public are detected by AMSI itself. So Microsoft and the other AV vendors have signatures for the AMSI, the public, at least the public AMSI bypasses, and they block them before they can bypass AMSI. So this one is also blocked, but the funny thing is if you execute this line by line, then it's not blocked because the signature in this case doesn't apply to a single line, but to multiple lines. And therefore we can bypass AMSI in this case even without doing any modification to the bypass. But if you are in an engagement or in a penetration test or something else, normally or not always, you have a UI. You don't always have RDP or something else. You cannot access PowerShell directly. So normally you are loading a script from a web server or something else like this. You put it like this somewhere and try to load it, and then it will get blocked. So this is the normal behavior. All those other methods are either not working or as well blocked by Microsoft. We can try that one here, for example. Yeah, it's also blocked, so we can't do anything at the moment, but it's really much in the chat. Yeah, I could use WinPawn to bypass AMSI, that's true, but WinPawn itself is blocked by AMSI, and it's really, yeah, that's the first thing which I'm going to show, how to modify this to not get it blocked or to execute it still. So if I try to load WinPawn, this one is also triggered. There's also a signature for it, so you can't directly execute it. And I just removed 1 or 2 weeks ago, I removed the AMSI fail script, which was contained here, because the Cloudflare worker from Flunkwick was removed because there were too many requests for AMSI fail. So AMSI fail itself still works because this is JavaScript and this is not using the Cloudflare worker. But the Cloudflare API was taken offline, so this cannot be used anymore. Yeah, and to make it short or to explain, if we want to get one of these bypass methods working again, if we want to make them work, we can manually modify the bypass itself. I wrote a blog post for that in September 2020 and on how to do that. And we will go, or we will quickly, you can read that. I will post it in the chat. If you didn't read it, you can read it afterwards. I think the general thing on how to do it is explained there. And now we can, in this moment, stick to one of the bypass methods here. I want to stick to the one which I added via pull request. Upsala. So this one is the same bypass that I just used here. So patching AMSI DLL by Rastermouse. The same bypass is included in AMSI fail, but AMSI fail already did pretty good, yeah, let's say obfuscation to make this work again. At this time, the AMSI fail payloads are still detected by Defender and by other AV vendors. So this cannot directly be used because we still have to modify it. But you can see the load library. Here we have the things that are normally flagged by the AV vendors are the words AMSI-DLL, the word AMSI-ScanBuffer, the word AMSI-Utils. If you somehow modify these values or split them, for example, you don't use AMSI-DLL but AM plus SE.DLL, or you don't use AMSI-ScanBuffer but AMSI plus scan plus buffer. This breaks the signature, or it broke the signature at that time. And AMSI-fail is actually replacing the same things. The load library here was or is AMSI-DLL, but it's char encoding, and the char encoding in addition makes some operations so that there are more random values, and these parts of the script are not the thing that is flagged here, because this is randomized really good in AMSI-fail. So the AV vendors gave up to flag on either AMSI-DLL or AMSI-ScanBuffer because these values change every time. If you generate a new one, the chars and the mathematic operations here, they change every time. So you can't you can't easily build a signature for that. But the thing that is the same in every generated bypass on AMSI-fail is or are the patch bytes. So you're taking 1, 2, 3, 4, 5, 6 bytes to patch AMSI-ScanBuffer, and these 6 bytes are flagged by the AV vendors, or the it's more or less how or in which row they are. So you can, it's if B8 comes first, then 5.7 comes at the second time, null at the third one, and 0.7 at the fourth, and so on. This is flagged, so you can basically go there and replace them. You can make the 0.0. You can do it to the on the last place. You can do this here, and you can, for example, also place the virtual protect somewhere in between, and this should be enough to bypass AMSI again. Yeah, because the signature in this case is here. So if you just randomize these values or put one on a different position and the next one on another position, then you can bypass AMSI again. In this case, it returned true, so the AMSI-DLL was patched successfully, and we can afterwards execute basically what we want again. So manual modification is, if you know what you're looking for, is basically the in my personal opinion, easiest thing to get a bypass working again. But you can of course also use any obfuscators or scripts to make it work again. For example, you can use Invoke-Obfuscation, or you can use ISE-Steroids or other things. I can show you ISE-Steroids one more time because I used ISE-Steroids in my pretty early time really often because it's just easy, and I also buy the license for that. It's something like $20, and it's a lifetime license, so you have to pay one time and you can use it as long as you want. Normally it will expire, but in this case it will not expire. Let's see if we can modify one of those values with ISE-Steroids to get it working. So put that in here. Okay, it's in this case the ISE-Steroids process was already patched, so AMSI is already bypassed. I have to open up a new process. Yeah. So, and if you are using ISE-Steroids, you can go on Tools, you can say Obfuscate Code, you can say use binary values, and you can say OK. And then the script is obfuscated. So every variable is randomized. You have here UDCCPT, which is now a binary value and a randomized binary value. Assembly get type was UDCCP. It's now the same value. Null was not changed, and in this case, it's a pretty easy obfuscation, because all the values which are strings, like for example right host or something like that, they are all just base 64 encoded. So it's pretty simple obfuscation. Let's see if this works. Yeah, it already worked. So if you just say obfuscate, and yeah, we actually bypassed AMSI by just using ISE-Steroids this time. So this is really simple, and yeah, you can use this to invoke Mimikatz again, for example, or WinPawn. WinPawn was blocked. You just saw it, and now we can load WinPawn. We can execute it because we bypassed AMSI here, and that's just by modifying the original original bypass. But I didn't use the original bypass because AMSI fail is still really useful. If I modify an existing bypass, I'm modifying one of these ones here, because they already do a pretty good job for obfuscating the values AMSI scan buffer, AMSI DLL, and so on. So you don't have to do anything for these values. You only have to look for another thing. One interesting other bypass method for this one is, or which can also show you this one. I have this in my head. I just tested it some time ago, but most times the thing that is flagged here is not the part in the middle, but I think it's something from the beginning to the end with the set value. If you set value non-public static at the end and set value null true, this is going to get flagged. So if you remove the null value, for example, let's first see if it's really flagged. Oh, this one is not flagged, but Defender caught it. But Defender still caught it. Okay, so this one, I think this was not a signature in this case, but I think Defender killed this process because we have to show you the default bypass to see how it works. Forcing an error, AMSI session, non-public static. So in this case, AMSI context is set to null, and if you set AMSI context to null, then you force an error, and AMSI cannot analyze anything. But I think that Defender, in this case, saw that we modified this value for the PowerShell process. We modified the AMSI context value, and this is more or less I don't know if it's the correct pronunciation, but an heuristic detection that it's checking AMSI context was set to null, and if it was set to null, it kills the process. This was not a signature. So just some zoom. So can't you see it that good here? The problem more or less is that this is 4K, and it's a 4K monitor. So I already set this value here to 150%, but the 4K makes everything else really small. I can do this. Now you should see it. Oh, okay, but this was still caught. Yeah, I also wrote another blog post on, just to explain it in short, on the difference between PowerShell only and process-specific AMSI bypasses. And most of the bypasses here, like forcing an error, disable script block logging, disable script block logging is not really an AMSI bypass, but this one is an in-memory patch. This one is an in-memory patch. This one is not an in-memory patch, but PowerShell specific. If you're using one of these here, they are only setting PowerShell specific value to true or to null to break AMSI for the PowerShell context. But if you're using one of these bypasses, you cannot load, for example, .NET binaries afterwards. So at this time, I'm not a single time using one of these bypass methods. I'm basically, if I use an AMSI bypass, I always use an AMSI bypass that does in-memory patching for the AMSI DLL, because it's just the safer way. It's if you load something in .NET afterwards, then you're on the safe side. If you are using one of these bypass methods here, then you can't load, for example, .NET afterwards, because it will get blocked by the .NET anti-malware scan interface. It's not the same. The .NET AMSI's anti-malware scan interface applies. I think it applies to the process which compiles the .NET part on runtime. So, and if we take a look at, for example, PowerShell pack, which also all this credit goes not to me, because I was only the one that collected all these .NET binaries, and I was just embedding them in a PowerShell script. So I didn't write any of these, or maybe one or two of these scripts here, but or binaries, but I was only putting them in a PowerShell script so that they are easy usable. And in this case, the .NET binary is decoded on runtime and loaded via system reflection assembly load. And if you do that, you will trigger the .NET anti-malware scan interface. And the .NET anti-malware scan interface will analyze the C# binary, which is decoded here and which should be loaded. So this will get blocked even if you bypassed AMSI via, for example, Matt-Graeber's reflection method. So you can't use this one to execute any PowerShell script that loads .NET binary afterwards. You have to patch or you have to do in-memory DLL patching. So basically, the one that I prefer is the one from MasterMouse, this one. If you patch that, or if you do that and load the binary afterwards, I can just show you that, because I think this desktop here will get a really mess if I let all those windows open. So one time again, using one of these. Or we do it easy this time. We execute it line per line, because line per line is not blocked. So we just bypassed AMSI. Here we got the true back. So if we want to load, for example, certify, which you should really take a look at if you didn't already. It was all the ADCS attack vectors which were introduced on Black Hat this week, and the paper was released like 45 days ago or something like that. This is really nice to know, and you should really read this white paper here too. But this is not about FR evasion, but still I'm gonna put this here because you have to read this. It's awesome, and the new attack techniques are also awesome. Yeah, but I took this certify binary, for example, to make it usable from within PowerShell, so that we don't have to put a binary on disk. You don't have to put a binary on disk to execute any .NET binary. You can just load .NET binaries via assembly load, so you can do that in memory. But in this case, we were able to execute it. But I also think that certify is not the best thing, because maybe there is no signature for certify now. But I'm pretty sure that there is a signature for example, internal monologue. So this one should get flagged normally. No, and we were able to execute it because we did an in-memory patch for AMSI-DLL. So, but patching or using an AMSI bypass is only one way to bypass AMSI. There are several more ways, and you can, for example, just use PowerShell in version 2. If you're using PowerShell in version 2, then there is no AMSI, actually. AMSI or PowerShell version 2 is not able of using AMSI, so you can check the version with PS version table, PS version major, for example. And this is now version 2. And just to show you that if you normally open up PowerShell, we have in this case PowerShell version 5. And if we want to run, for example, PowerUp, which is one script from PowerSploit, it's not the script to go in my opinion today, but yeah, I just choose this for the demonstration here. If you want to have a nice script for privilege escalation vectors, I would not use PowerUp today. I would use Itman's PrivEscChecker. So in this case, PowerShell version 2 has no AMSI active, so we were able to successfully load PowerUp, and we can afterwards use the function Invoke-Obfuscation to make privilege escalation checks for this current system. And it works because AMSI is not active here. But there were more protection mechanisms than only the anti-malware scan interface introduced. One of these is, I'll just close this here. One of the protection mechanisms is, or countermeasures, is logging, because there was a time where logging was not possible for all things that were executed inside of PowerShell, or all things that were loaded. And I have to wait a moment here. But Microsoft also introduced logging here. So I will show you how script block logging works and how it, just check the chat. What I'm using instead of PowerUp, I'm using PrivEscCheck, this one. Itman is a person. He puts pretty much effort into everything he publishes, and this script here is really the way to go, in my opinion, to check privilege escalation vectors in this time. Yeah. Or you can alternate. I also like WinPairs. WinPairs is a .NET binary, so I didn't want to use this .NET binary as it is. So I also added WinPairs to PowerShell pack. You can also use invoke WinPairs to. This is also a good alternative for privilege escalation checks. Yeah. Okay, so let's see if this is loaded now. Yeah, it's loaded. So the logs for PowerShell are normally saved here. PowerShell operational. It's the operational log, and we have script log logging here. So if you, as you can see, internal monologue, for example, I just loaded internal monologue and executed it afterwards, and you can see the event logs with the ID 4104. These are the ones that contain pretty much everything or every script or function that was loaded. So if you have an environment where the customer or the whatever company collects logs on the endpoints and sends all these logs, for example, these ones, to a central system like CM system or a logging collector, whatever. And if they analyze all these content, it would be pretty easy for them to see that we were using invoke internal monologue in this case, because it's just logged, and they can, for example, make a query over all systems to see is this or this or this string executed somewhere on some system, and then they will see, or they can query for invoke Mimikatz or for anything else, and they will just see it because everything is logged. So invoke certify was logged. So this also is one method to detect attackers that are using PowerShell, or at least the built-in native PowerShell executable from the Windows system. But there also are or methods were published to bypass this script block logging. I have two examples here on how to bypass script block logging. One example is, I didn't put a reference in here, but it's from, I don't know how to pronounce him. Ryan Kopp. It's from Ryan Kopp. He published this one. This is basically, it's a little bit like the AMSI bypass methods from Matt Graeber here. It's modifying some values for the current process to set them to null, and if you set them to null, then nothing else is logged afterwards. So this one will get logged, but anything else afterwards will not get logged. This is one method to actually bypass script block logging. And you just saw that everything which I did here was logged. If we now disable script block logging, load this script, which is at the time of writing not flagged by AMSI, then we can afterwards, we need an AMSI bypass first. This time I'm going to do it quicker because I don't want to modify all the bypass methods all the time again. So this is just a short bypass method for this stream to be a little bit quicker. It's basically the raster mouse bypass, the same which I just did. It's just these values here changed, and then I'm faster here. So this one should not get logged here. And if we look at the time, 2:45 p.m., we can afterwards load internal monologue. So we should not see anything here. So the only thing we saw, even the script block logging bypass itself was not logged in this case because I think because it's no function. If I do a function around that, bypass, something like that, then it should get logged. Just try it. Stream PowerShell logging. Disable logging reflection. If we call this function bypass, we will see, yeah, the function was logged. So if you don't have a function, it's not logged in script block logging. But there are other events, I don't know how it's called, but there are also other logging techniques. I think that it's also possible to log not only functions, but the last bypass was not logged. In this case, it was logged, but everything afterwards was not logged. So we can again patch AMSI in memory, load internal monologue, and we can execute it, and we will see that we see nothing. So we just bypassed script block logging, nothing is logged. So if you have an environment where this is in use and where they send all the logging information to a central system, then you can bypass, or you can at least bypass logging for everything after the script block logging bypass itself. Normally the script block logging bypass is shown, so they can flag for that, for example, but they won't see anything else. And we can, just to make sure and just to show it, I was just talking about obfuscation and about obfuscators. And I have something here. I just used ISE-Steroids as one example. But we can also use Invoke-Obfuscation, for example, and it's old. Old in forms of maybe 3, 4, 5 years, but it's still pretty usable and still pretty good, and it still works. So you can still use this one to do obfuscation, and it's still really useful. Invoke-Obfuscation PSD. Oops, I didn't patch AMSI before. This one patches AMSI. Then we load Invoke-Obfuscation. I should have used quiet because this banner can be avoided, but yeah. So normally we can, yeah, I had prepared one, but it's also somewhere here. Quiet option. Invoke-Obfuscation, no, not this one. This one, minus quiet. Yeah, there's an example. Script block, word for Invoke-Obfuscation. Token or test quiet. Not the best preparation, but I think tutorial show help set, there was something like set script or script path. Oh. Tutorial. Set script block, okay, or set script path. There was this set script path, this one. So stream PowerShell logging. Just to show you what this tool is capable of. We can obfuscate it one time with Invoke-Obfuscation. So we have the script path. Now we can, for example, say we want to obfuscate tokens, we want to obfuscate strings, and we want to do something like this with a string. If you have a string like coffee, it's just splitted. So this tool automates the process of splitting values, for example. And now we can see the result. And the result is the same function, but if you had system management automation utils here, for example, it's now s plus isdim plus m plus ma plus n and so on. So this is splitted, and this is one way to bypass signatures or AMSI signatures. Because if the string that was flagged was, for example, system management automation utils, then in this case it would not be flagged anymore. We can say we can go back. We can say we also want to obfuscate arguments, something like net web client. In this case, the lowercase and uppercase values are changed to random case. We can do that. Now we have random case for all those. We can use 2 to add backticks, and the backticks are also applied to all these argument values. In this case, there's only one argument token. It's not the best example. Or we can obfuscate variable values. We can say we want to obfuscate the variable values. And before we had group policy field here. This was one variable. And this is now dollar group policy field with backticks. And yeah, if you have a signature for variables, in this case, it would also not get flagged anymore afterwards. And one thing I really like in the case of, for example, script block logging is the white space encoding. Nope, not this one, but encoding back. Here we have some encoders. We can say we want to encode the whole script. We want to encrypt the whole script so that the whole script is encrypted and decrypted on runtime. We can convert the whole script to ASCII, to hex, to octal, to binary. We can convert it with binary XOR, or we can make the whole script a white space. So if we do that, it gets pretty big, but we can afterwards, just to show you how this looks now, out. Let's see, stream PowerShell logging. Oops. Yeah, this is how the script looks like now. You have one single quote. You have only white spaces. The whole command is white spaces now, the whole script. And at the very end of it, no, can't even find it. At the very end of the script, there normally is a decoding for the white spaces, so that all the white spaces are changed back to something usable. Here it is. So AV vendors can go and make signatures for this white space decoding as well. But I think this technique is really cool because if you lock this function, we can do it. So if we go to C stream PowerShell logging, and if we load our off script, which is not detected in this case, and if we execute the function bypass afterwards, we can see that this is the script block text. So you can't actually see anything in this. This was the old one. Oh no, it's decoded. Is it decoded? Oh, I have to retest this. it's decoded, then everything I just said was wrong. I thought that the white spaces were stream, PowerShell, logging, ops, bypass. So this is the bypass function. Yeah. Actually, you can see that you can see nothing because everything is white spaces. You can see the whole command if you forward this log, but I think this is pretty cool because even your script block logging bypass will not be seen or detected in a central logging instance. Okay, so this one way to bypass script block logging. I think there were no additional questions here in the meantime. So I'm going to show one alternative technique. It was published by BC Security not long ago. Part 1, Part 2. This one here. It's already 1 hour now. I think my time plan will not work. This will take much more time than I initially thought. I have many more things planned here, but yeah, I'm talking too much around other topics that I didn't plan to talk about. So this blog post, I will just do it into the chat so that you can take a look. Also explains another method to avoid script block logging. Basically, you can, for example, load a script or load it from the internet and put it into a variable, and then you can create a script block with the .NET function script block create. You can put the content from your script in that, and then you can set the value has logged from this newly created script block variable to has logged, so that basically it's like this script block already has been logged, and because this value was set to has logged, it is not logged anymore afterwards. So we can basically say to Windows, hey, this one has already been logged. We can afterwards invoke it with invoke. The script block is executed, and then it will not get logged again because the value has logged is already set to true. I think this is also a cool technique. We have 2:58 p.m. If I execute this one, this is the AMSI bypass, by the way. And it worked again. Then we can look at the script block logging functions here. And we will see that a script was loaded. Yeah, okay. You can also take the content from here, but the content itself is not logged. The only thing that is logged was the C# part of the script, because this is not using the same logging function. If you use @type to import something from C#, this is basically C# code, and it's importing some Windows functions. If you're using @type, then this is compiled at runtime and temporarily put on disk, and but the rest of the script was not logged. So this part here is not logged anywhere. You cannot see this here. The only thing that is logged is the @type and the content from the @type. Yeah, that's a second technique to bypass script block logging. So, but there are more techniques to stop attackers from using PowerShell or offensive PowerShell. One more example is constrained language mode. And if you have constrained language mode enabled, basically many functions or many extended functions from PowerShell cannot be used afterwards. So you can enable constraint language mode for at least for the current session with this command. We can set the execution context session state language mode value to constraint language, and afterwards we cannot use any advanced functions, or any in most cases it's the .NET functions like net web client, whatever. You cannot use them anymore because they are not allowed. And if constraint language mode is active, then you cannot use these types in the language mode, and then you basically cannot use any offensive security PowerShell script which is public anywhere anymore. You can of course use the basic functions like get child item, whatever. So, but you cannot use something like IEX, new object net web client, or all the things that are used in here. You can use add type, at least I think so. Oh, you can use add type, but we can take a look if it's been experimental here now from my side. Yeah, okay. Cannot add type because definition of new types is also not supported. This, for example, is not allowed anymore. And if you have constraint language mode active, you cannot do anything anymore. If you have PowerShell version 2 active, and I didn't show up how to check this. For example, PowerShell version 2 has nothing to do with PowerShell itself. I was often asked by customers if they disable PowerShell version 2 if PowerShell is not working anymore. But this is not the case. If you disable Windows PowerShell version 2, then PowerShell, of course, is still working, but only the version 2 is not working anymore. But with PowerShell version 2, you can also bypass constraint language mode because it doesn't apply to version 2. I'm jumping around here with the topics. Not the best thing to do. But one way to, or multiple ways to bypass constraint language mode, or my favorite way is using a C# run space in C#. And I have two examples here, the MSBuildshell, which was published by Cornelis, who works at Outflank, and I have another example, PSBypassCLM. And I will show both and show you how to use them to bypass constraint language mode. If you want to bypass constraint language mode, you will not use the built-in PowerShell exe from Microsoft, because constraint language mode applies to, it's not this directory, Systems 32, Windows PowerShell. So all the countermeasures apply to this executable here. So you can, for example, also compile your own PowerShell exe and remove all the security features, copy your own PowerShell exe to the remote system, and you're fine to go, and you can bypass AMSI, you can bypass constraint language mode, and you can bypass script block logging because the features are not available in your own PowerShell. And the MSBuildshell and PSBypassCLM basically build up a new C# run space. I won't go into detail here, but in this case, I made a fork from the original Cornelis repository and added a new or another AMSI bypass. He had I think it was an AMSI bypass which dropped in DLL to disk, and this DLL was loaded instead of the regular AMSI DLL, and I removed that one and added a new one which packages AMSI in memory. So my fork actually contains this raster mouse patch method, And if you want to start the MSBuildshell, you can do that via Powershell CLM. Oops. You can do that via this command. You can use MSBuild and compile the project on runtime. Yeah, does not exist. Makes sense because it's not in this folder. Don't just copy paste. So in this case, a virus was detected because this sample is public. Everything that is public is flagged sooner or later. And so if you ever plan to do anything and if it's ever flagged, don't modify it and re-upload it, because if you re-upload anything to GitHub or some else platform, then it will get flagged again, and it's an effort and again an effort and again an effort to modify it and to modify it. I did this for fun with WinPawn, for example. There was a time when I added a new signature to bypass AMSI every 1 or 2 days, but Microsoft is that fast with pushing new signature updates that it really makes no sense to use or to make the effort on updating signatures every time. It's really not a good idea. In this case, I think I already had Visual Studio installed, but we can modify it manually as well. In this case, I already know what the trigger is. We have a namespace which is called AMSI. We have a class which is called bypass. And one really simple way to bypass this signature is we are, for example, replacing AMSI with signature, replace all, and we replace bypass with hello, for example. So we replaced these two words here. And just to show you, the error could not load the assembly, could not complete because the file contains a virus or potentially unwanted software. Okay, so this was an obvious message here. So I modified this to signature and to hello, and we again execute this via MSBuild. And now we have the MSBuildshell running, and AMSI was patched for the MSBuild process. So we already bypassed AMSI in this case, and we can afterwards use this like a regular PowerShell console. And for one example we can use is we can just run, for example, WinPawn to show you that this works and that it's not flagged. No. So we're loading WinPawn. One downside of this tool is that you don't have a verbose output. You don't see any error messages or something like that, but you see the normal output. And in this case, you could normally run the WinPawn function. Something didn't work here. Yeah, it seems like the AMSI bypass of WinPawn didn't work here. So we have to also modify, at least in this case, we also had to modify this AMSI bypass because it's a different process, or it seems like that's a different process, and the MSBuildshell process doesn't execute this. But if you want to get rid of this, you have to modify the AMSI bypass that is built in WinPawn. Then you would also get rid of this. In this case, all PowerShell scripts will work, I'm pretty sure. You could say, for example, local reckon. We can say collect computer information, and this works and will generate all the output that we have normally. But all the .NET binaries don't work here because we have to modify this bypass before. So MSBuildshell is one way to get rid of constrained language mode, and it uses a separate run space. So in C#, I didn't plan to explain this here, what a C# run space is and how it works and how it's done in terms of code. But basically, you can say this is my new PowerShell run space. I want to remove this and that feature, and I want to create a new one. And then PowerShell or the PowerShell executable is not used for your command, but the PowerShell commands are directly sent to the .NET API. At least that's my understanding from it. And if you do that, you're just bypassing every countermeasure for PowerShell or protection mechanism for PowerShell, because in the run space nothing is detected. One more example, and in the meantime, which this one is loading, I can show you more examples. Because I have a repository which contains basically everything that I currently or that I use. Constrained language mode. So most of these tools or binaries can be used to bypass constrained language mode. And yeah, you can just take a look at these and you can use the one that you prefer. Insecure PowerShell is, for example, which I just told. It's PowerShell, but all the security features were removed. So if you compile this PowerShell, then you have your own PowerShell, which doesn't contain AMSI support, which doesn't contain script block logging, with no constrained language mode active, and you can just copy the PowerShell to your target system and execute it there. And then, yeah, this is also one way to do it. And InvisiShell is, I think, one example in C++, which also uses, yeah, it's C++. So you can also use or build a new PowerShell run space in C++. So this is not .NET related and C# related. You can also do this in C++ and use this, for example. But going through all these tools is way too much. And building new code, I think was at least too much for this stream as well. Yeah, I'm going to show PSBypassCLM as well here. Going to build the solution. This, like the MSBuildshell, also has an AMSI bypass embedded, or it has two AMSI bypasses embedded. This one here is, oh, I'm missing system management automation. This one here is decoded at runtime and put in the current directory. So it's a fake AMSI DLL, which has basically the same function but returns true every time and not malicious, like that, for example. But I have to add system management automation. Oh, wow, that fucks. Oh, don't have that in my head. Resources. Normally I'm doing this in German, so in German it's Verweis. Good question, how to add in Verweis here. Dependencies, no, this not. References, there's no references. Add reference, Verweis. So system management automation, system. Where is system management automation? System management. Maybe this already contains automation. I'm not sure. Nope. System management automation does not exist. This sucks. System management automation location. Or we can add this as nugget. Yeah. So this should now at least build. Oh. Warning! Automation version could not be resolved when it's installed. Don't suck. Don't suck. I don't want to spend too much time on this because I think my time plan at least doesn't go up. In this case, it's just too much time. So I'm going to try or take a look at if it's contained here. Yeah, it's contained here. So I'm not going to build it. But I'm not just going to use it from here. Yeah, it was detected. No. Hope it's not directly flagged. Stream. Powershell. CLM. It was flagged. Sure, it was flagged. View raw. Copy. PowerShell. CLM. This folder is excluded, by the way, so if you wonder. And in this stream, I'm not going to show how to build an or how to modify C# binaries to get rid of signatures. In this stream, I'm going to show how to avoid PowerShell protection mechanisms. So this is not the scope of this stream to show how to make or how to build C# binaries which won't get detected by the AV. I think I'm going to show this in the next stream on how to modify C# binaries and which obfuscators to use for C#. So next time I'm going to show you how to do this, and I'm going to prepare this with system management automation. This is obvious and fail from me. Yeah, but this version from my repository should also work. The signature is detected, yeah, but it's just to show you that we can execute PowerShell commands from inside of this separate run space. So this is now the PowerShell run space from, okay, I can copy paste. PowerShell run space, we can now say winpawn. And we don't get any output. Okay. I think I know why this happened. I think we can only execute one function per time. So I'm going to execute the winpawn function directly after loading the script at the end. this should work. No, cannot add type. CTCSV already exists. That's the demo effect. New object, net web client, download string. Okay, can show you that here in the moment. Yeah, this sucks, but I will show that in the next stream. I think I will prepare it better, but it definitely works. You have to trust me here. One method already worked. The MSBuildshell was pretty easy to modify and to get it working again. PSBypassCLM is also pretty easy to modify. You just have to modify the AMSI value there, and then this will also work again. Okay, so let's take a look. What I prepared to do next. Yeah, the thing is with PowerShell, you don't want to drop anything to disk anytime. The nice thing with PowerShell is that you can basically load anything directly to memory, and it's so easy. I still prefer using PowerShell in many environments, and in a penetration test, or especially in a penetration test, it's not necessary to avoid detection. It's okay if you are detected. You can make fun for yourself to try not getting detected. I'm often doing this, but we can be loud, and therefore we can also use PowerShell. It's pretty yeah, pretty fine. Say if you're doing red teaming, then and the goal is to not get detected, then yeah, using PowerShell is not really a good idea. You can still use C# run space and run PowerShell scripts from there. This is still possible and still easy, but I would not use the built-in PowerShell executable if the goal is not getting detected. I would not do that. Yeah, in my blog post, I also showed ways on finding the signature for PowerShell scripts, and one way to do that is using AmsiTrigger. I will just post the link for AmsiTrigger here as well. AmsiTrigger. Really like this tool to find signatures, because someone posted the URL for the system management automation. Thank you. That's the stress of doing the first stream in my lifetime here that I'm doing, that I didn't found it. Still going to show that for the moment. To find a signature via AmsiTrigger, you can use this with the parameter -e. You can provide the script that you want to scan for triggers, and then it will build chunks, or will split up the script in chunks. It's very similar to ThreadCheck and to Defender. I mean it's Defender check. ThreadCheck is the version from Rastermaus, and Defender check is the version from Mattgräber, and they're basically both also splitting up a binary to chunks and analyze these chunks for a trigger. And AmsiTrigger Oh, in my blog post this was pretty well explained, but I have to take a look at the code again. It makes chunks from the script, and then all the chunks are analyzed via AMSI is initialized, and afterwards it will use it's using AMSI-DLL to scan all the chunks, and if the AMSI-DLL returns malicious for a part, then this is blocked. This is also the best demo effect here. Nothing works. Stream. Yesterday this worked. Defender killed itself. Okay. It's detecting power view and saying no, you can't use power view here. And AmsiTrigger is detected. Yeah, that's bad. Don't know why this worked yesterday. Sometimes this really makes no sense. Check real-time protection is enabled. Yes, I know that real-time protection is enabled. Real-time protection is enabled. Huh. I don't know what's happening here. I'm sorry. All demos don't work here at the moment. Yep, I'm going to show, or my plan was to show Obfuscator in the next stream. There's one disadvantage in Obfuscator, and that's many times when I was using it, the source code didn't work anymore after obfuscating the code. And often I had to manually fix the errors after using it. But Obfuscator is really, really good in terms of obfuscation. So this was my plan to show it in the next stream. Yeah. I'm jumping here and there because nothing's working. So you just put the path to the DLL here. Let's see if it's there. System management automation. Here's nothing. Nope. This is empty. But I'm also wondering why the nugget package is not found here. System management automation is installed. System management automation. I don't know. It's at the bottom. At the bottom here. Already exists. This is so strange. System management already exists. I don't know. I think finding the right path is not very it's not very interesting for the others. Most likely. Oh, this is system management automation, that's correct. But still failing. Using system management. This is not needed at all. This is not needed at all. I don't know. I will prepare this for the next time and we'll show it in 5 minutes because this time it's just my stupidness. This can also be removed here. But it's not the thing. I don't know why this doesn't work. I mean, it's included here, but it's not found. I don't know. So this the last try I'm doing, removing the Nugget package and manually loading it. Failed. System management automation could not be resolved. This makes no sense. I don't know. I will check it. This also makes no sense. But I think I will just reboot the system one time and maybe it will work afterwards. Sometimes Windows is a little bit strange. Strange behaviors. But in general, AV evasion, I often saw people asking others in the community on how to bypass AV, and then they just said, yeah, build your own code. That was the answer many times. Just build your own code, and that's pretty much the #1 way to go to bypass AV, to build your own code and to not use the things that are publicly available, because if you build your own code, there's no signature for it. All AV vendors use signatures from those things that are publicly available and from malwares used in the wild. So if you build your own code and if you do everything from scratch and not use the things from public toolings available, then we will be really fine to go evading nearly every AV. But we have one problem with this approach, and I think this problem especially is true for penetration testers, and that is time. We don't have unlimited time, and we don't have so much time to just build everything from scratch because time is limited. So let's just check if this And I'll do temper protection off and cloud protection off, but real-time protection on. Real-time protection is enabled. This makes no sense. I think I have AmsiTrigger also here. So we could try see don't scan AmsiTrigger. Powershell, power up. I don't know why this is like it is. Yeah, and it's true. Since I can't do everything public or everything that is public is flagged, it's clear that you have to build your own repository or your own instance with everything that is public encoded or obfuscated, and you can't publish this, because if you publish it, then everything is flagged again. And on my team at Artec, we have a repository where all the C# binaries and all the PowerShell scripts are included, and all of them are obfuscated, so we can use all of them in our engagement without having to worry about AV, because most of them are not detected. And yeah, also NIM binaries. Everything is decrypted on runtime. That's pretty nice to have a repository like this. But you can make it public, because if you make it public, it's everything is flagged. That's clear. So NIM will be the last. I think this will be the last stream. I cannot do a stream every week, but I think every 2 or 3 weeks maybe this will work. And NIM is planned to be the last one, to show you how you can build your more or less payloads in NIM without them being detected. There are really good possibilities. The offensive NIM repository from pipe leaders. Also really good to take your templates from there. This one. But I think especially you should have seen it, because you are talking about NIM, so you will know this one. Yeah. So, do you know, was a question, do you know a good obfuscator to protect my code from being analyzed? Protect your code from being analyzed. Do you mean, I don't think that you mean PowerShell code, right? Yeah, and the Roslyn is for .NET, Gabel for Go. I don't have to solve this question. But you can also, if you have PowerShell, you can also use Invoke-Obfuscation to protect your code. Pyfuscation is another example which I wanted to show. This is one thing or one possibility to obfuscate code. Bash. The strange thing is that this is written in Python, Pyfuscator, but it doesn't work on Windows. I didn't have the time to troubleshoot this, but it didn't work on Windows, so I did build another version or a new version via Windows subsystem for Linux. -h. Let's just see. So if you're using Pyfuscation, we want to obfuscate functions, variables, and parameters. Yes, all of them. And we want to obfuscate a script. And we can say, for example, that we want to obfuscate WinPawn. Like this. And the nice thing from Pyfuscation is that it's replacing all these values. There's a word list, and the word list contains default normal words from the English dictionary, and all variable names, all function names, and all parameters are replaced with random words from this dictionary. This has the positive effect, let's say it like this, that the new script will most likely not be detected anymore. But it is also, the downside is that you have to remember all the new function names, all the new parameter names, and all the new variable names if you are using the variables. So, and in this case, I'm obfuscating WinPawn. There are 175 variables which are replaced. There are 50 parameters which were replaced, and now it's replacing 87 function names. And it's also placing all the translations from the old function name to the new function name in a separate table. So you can, if you have AMSI, or if you had AMSI bypass before, it's now fix. If you had dependency checks before, it's now ASHI. If you had path check, it's now dressmakers. Sharp cradle is now genetic. So you have to use this. If you normally remember these function names, you can you have to look them up afterwards, because yeah, it's hard to use a script if you don't know how to use it. So this is now, everything is now replaced. We can now look that up via ISE-Steroids, not ISE-Steroids, but ISE. This is the initial AMSI bypass. This should also, or this should still get flagged, because only the variable names were changed here. I think that this is still flagged. We will see. Yeah, this is still flagged. This is because the AMSI bypass is flagged. If we take the AMSI bypass out for a short moment, yeah, it's not detected anymore. So it's the same thing here. We have to replace these values to get a not detected version. And if we're doing that, then we should be fine, at least fine from AMSI. And we could now say, for example, we want to bypass AMSI with this new function, and AMSI was bypassed successfully. We don't need to bypass AMSI in this case, but it was just for fun now. And if we want to execute the WinPawn function, for example, it's now overturns. And overturns is now, okay, path check was not translated correctly at one point here. So it's not 100% correct translation here from the tool. But in general, this is a good approach, especially for implants. So if you're using a command and control system, and if you are using any agent or a stager, then you can use this approach of replacing every variable, every function name, and every parameter, because it doesn't matter. You're not using, or the implant is normally executed on the client side somehow from someone, or it's in AutoStart or whatever. And you don't have to worry about the function names, because you have an entry point somewhere, and this is most likely not PowerShell. In C#, for example, you can do that. Then you have an entry point, the main function is executed anyway when the executable is executed. So if you're replacing every value there, then you're good to go, because the binary still works as before. And you don't have to remember all those function names, because it's just executed. Yeah, if you're using this for your daily scripts on daily tasks and for your lateral movement, privilege escalation, post exploitation tools, then you have to use this translation table to know what to do. This is the downside, but in general, I think this is another approach. If you're using Invoke-Obfuscation, this is not done. So you have the same parameter names, you have the same variables, and you have the same function names all the time. And it's just, oh, we can look that up as well and do this again for WinPawn just to see it. Bloop. Stream, PowerShell, Obfuscators, Invoke-Obfuscation. So I have now my AMSI bypass, this one. PSD1 Invoke-Obfuscation is quite doesn't remove the menu. Okay. Set script path C stream PowerShell WinPawn. So this is the script path. We can say we want to obfuscate tokens, we want to obfuscate strings. Now it's a little bit more. We have 1,557 strings which were replaced. And it looks like this. Also, just to show you, this single obfuscation makes WinPawn work again, because the AMSI bypass is the only thing that is flagged in WinPawn. It's every time it's just the AMSI bypass. You just have to modify the AMSI bypass and WinPawn will work out of the box again. Stream WinPawn ops PS1. So this is the new one, and in this case the patch bytes for patching AMSI-DLL in memory were just splitted. So it's null x plus b8, null x5 plus 7, and this also breaks defender signature for this bypass. So which is pretty simple. It's just one thing. WinPawn ops. And this is loaded. But yeah, that's the thing that I faced yesterday in my tests as well. It seems like Microsoft and Defender now have an in-memory signature for WinPawn, which is pretty interesting for me, because I only saw an in-memory signature for Invoke Mimikatz before and for Mimikatz. So it was not the script that was detected here. The script was loaded successfully, but it looks like really they build an in-memory scan signature now for my script, which is really funny for me, at least. I think this is funny. I have to find out what exactly they are triggering. But I can show you another example which is flagged, and that's normally it's Mimikatz. Oh, not Mimi load, but load Mimi. That's the one that I'm using in WinPawn. Normally only this one is object net web client download string. Puts. Yeah, this is now flagged by AMSI. We know we're patching AMSI. So AMSI is patched. We're now loading this. Okay, reload. So this process should be killed now, because there also is an in-memory signature for it. That's the demo effect. Sometimes there's a strange situation that this process is not killed, and sometimes it's killed. Or most of the time it's killed. If you do that on your system, it will be killed normally. I don't know why it's not killed here. I have to reboot the system and do this again, and it will be killed for sure. Yesterday I had to do a reboot, and then I did the same again, and it was killed. So normally there's a signature for this one, but there was no signature for WinPawn before, yeah, which is a little bit crazy. So, but we can also do more obfuscation here, just, or we can do all. We're doing all token obfuscation techniques here. The downside of doing all obfuscation techniques is that most likely you will break the functionality of your script. So I expect WinPawn to not be functional after doing this here, because yeah, some of the obfuscation mechanisms here break functions or break the script, and if you try to use it afterwards, then it will not work. So normally I'm not doing all, but I'm using specific things for the token, specific things for the arguments, for the variables. No, no, we just did all. Stream more ops. So this now has all of the obfuscation, or at least of the token obfuscation enabled, but as you see, the function names are not touched here. The function names stay the same, only these parts, all these strings in the right host statements, all the content from variables in the double quotes, all these things are replaced, but many things are not. But I'm just wondering why, because normally I can say I want to make variable obfuscation. Something is again broken here. I think I'm good at breaking Windows with exclusions, and I can do login passwords in after rebooting here. And I can show you how to avoid the in-memory scan. That was my plan, to show you how to get rid of this in-memory scan. There are currently, I think there are 3 techniques to do that. At least 3. I know about 3 techniques, and I can show you those techniques. So just checking that everything is enabled again. Real-time, cloud protection, temper protection, looks good. So, and now I'm going again to patch AMSI, load Mimikatz, and this process should be killed now, normally. Ah, it's killed. Okay, so this is the in-memory scanner. The PowerShell script itself was not detected, but the in-memory scanner was triggered due to all those. Yeah, it's multiple things. It's or Mimikatz is loaded via reflective PE injection, and reflective PE injection is using multiple Windows API functions, which normally are hooked by AV vendors and by EDR vendors, and they can see if those Windows functions are used, and it's basically the same in reflective PA injection. Then if you for example execute shellcode in a remote process, it's the same functions, and they already make the script suspicious when it's executed. And the second thing is that Mimikatz loads several libraries. For example, semlib DLL, for example, ntdll, for example, many more. There are like 20 or 25 different libraries that are loaded by Mimikatz, and they are normally loaded in the same order. And if those functions are loaded, this is also one thing that triggers the in-memory scanner from Microsoft, at least from my current understanding. That's because nothing is written down, nothing is documented. I think that this triggers the in-memory scan, but I'm not 100% sure. And one thing to avoid this is make use of syscalls, for example. If you're using direct syscalls, instead of the normal pinvoke Windows APIs, then you will get rid of this detection. I did build a PE loader which does this. Initially I didn't want to talk about syscalls today. I just wanted to show the basics for PowerShell. Okay, I will not find it here because these are just too many gists. I think this will be complicated. Too many things. No. This will not be easy. This is called PE loader. This one. This is the one which I posted on Twitter. It's the PE loader from Subti, but I'm using dinvoke instead of pinvoke here for allocating memory and so on. And you can put your base64 encoded Mimikatz executable here, compile this, and then it's using at least dinvoke instead of pinvoke. And when I published this, it bypassed the in-memory scanner. So the in-memory scanner didn't trigger at all when using this. But 1 or 2 days afterwards, it was triggered again. So they are really fast. When someone publishes a technique, they're really fast to trigger it again. Yeah, but now I'm going to show you 2 ways which are pretty easy to avoid this detection. Windows PowerShell. So one way is just copying PowerShell exe to another path. You can copy it, for example, here. And then we have PowerShell in our stream directory. You can run PowerShell from here. Yeah, can't access the history, which is bad because I have everything in the history. But it's not that bad. Now we at least need administrative rights to execute Mimikatz afterwards. So we can just do it as administrator. Oh, we can still not access the history. Doesn't matter. So AMSI was bypassed successfully. True. I will take this from the history here. This is faster. Also, there's no history. Did Defender just delete my console history? I think. I have no history anymore. Oh. I deleted my history. My history contained too many malicious commands, so Defender thought, nope, I don't want you to have all this stuff in the history. Load mimi load. So we have all this active, and we're doing basically the same thing again, but only that PowerShell is now in the directory stream. And as you can see, the process is not killed. I think that this is due to Microsoft building a signature for the trigger, and the trigger is only, or the in-memory scan is only done if PowerShell from the directory Windows System 32, Windows PowerShell v1. Only if it's executed from this directory, then the trigger, then the in-memory scan is done. If the PowerShell is somewhere else, then there's no in-memory scan at all. This is one way. And the credit also goes not to me. This was a small discussion between me and Flankvik, and Melvin Flankvik, and he discovered this technique here. So this is basically, so, and you wanted to see my passwords. Someone said this. And you can see the password is null. The password is null. But if you want to crack this hash, then you will see that the password is not secure. No, it's not. This is not triggering the in-memory scan. The Mimikatz execution and the credential theft itself doesn't trigger the in-memory scan. It's triggered by the Windows API calls that are used to reflectively load Mimikatz into memory. So it's invoke reflective PE injection or subtease PE loader. The Windows API calls that are used there trigger the scan. Plus the libraries that are loaded by Mimikatz, these 20 or 25 libraries, they trigger. Yeah, but this works. So now we have another one. And the second one, you also need administrative privileges for it, is parent process ID spoofing. If you don't know what parent process ID spoofing is, then I'm gonna show you now. So I don't need this process. So we can take a look at our PowerShell process here now. And we're gonna take a look at our process. And normally, if you start PowerShell in a normal way, then the parent process is Explorer Exe. And parent process ID spoofing means that we can create a new process and basically set our own or define our own parent process for the process that has to be created. And there's a little PowerShell script that's also included in my creds directory. I found it somewhere on the internet. I didn't put the link in, but I also didn't write this one, but found it. And it's basically written in C# here, so it's using several Windows APIs to do parent process ID spoofing. And you can say, or you can, if you create a new process, you can specify the parent process as value here. So you can say create a new process with, well, I have to look, create process. There must be some create process API. extended startup info. Yeah, I think the parent process ID is placed in the extended startup info, and create process is the Windows API call to create the process, and we have the, yeah, here's the parent process. So update proc set attribute, the new parent process is placed here, and then we create this new process with the new attributes. So we can load this parent process ID spoof encrypt as usual, and then we can say we have to specify a process by ID. And I find it funny to choose Elsass as parent process because if you choose Elsass, and if Elsass spawns a PowerShell process which loads Mimikatz, I think this was fun for me, so I'm just doing it that way. Then I'm gonna do my process, create process from parent. I have to specify an ID, and the Elsass process ID is 668 in this case. I have to specify Windows PowerShell, and I have to specify arguments. I have no arguments, so this is our new PowerShell process. And we can take a look at Process Hacker again to check, and we will see that Elsass is here, and Elsass, it looks like Elsass spawned a new process, which is PowerShell exe. Actually, it didn't. We created this process and we like spoofed the parent process so that the parent process here is Elsass exe with the process ID 668. And now we can do basically the same here. We can patch AMSI-DLL. Afterwards, we can load Mimikatz. Load. And it's the same. This process is not killed. And it's not killed because it's only killed for some specific or if some specific parent processes are set. For Explorer exe, for example, then the in-memory scan is done. Maybe, I don't know, maybe the in-memory scan is also done here, but because Microsoft thinks that it's a sub-process of Elsass, it won't kill it, because if you kill Elsass, then the system will run into a blue screen. Maybe it's somehow a protection mechanism of Microsoft to not kill a sub-process of Elsass, because I don't know it. I don't know it, but it works. So if you want to execute Mimikatz and if you have problems with the in-memory scanner, then you can use one of these two techniques. And you can grab a coffee. And this works. So yeah, another thing to avoid the memory scan, obviously, is building a custom Mimikatz. If you build a Mimikatz with, if you modify the source code to not include the signatures that that Microsoft or the Defender is looking for in this case, then you're also fine. But yeah, obfuscating Mimikatz takes a lot of time. I did that multiple times, and it's not that you're doing that easy, and that there are some obfuscator tools to say here obfuscate Mimikatz. No, unfortunately, no. Yeah, building a custom Mimikatz. There's a blog post. Yeah, in the blog post, I'm also giving advice on multiple other techniques or there's a script at the end. You can use the script to build your own binary, which still works pretty good today. So for like if you upload this to VirusTotal, I did that 2 or 3 weeks ago. A freshly built Mimikatz binary using exactly my gist from here. But where is it? Where is it? Where is it? Ends up in this gist. Yes. Not good. And what's up with this? This one. If you're using this bash script, then it will more or less automatically remove several signatures from Mimikatz and replace several words, and this works for many vendors at the time of writing. So I checked this 2 or 3 weeks ago, and it's still not detected by, or it's only detected by, let's say, 20 to 25 vendors on VirusTotal if you upload it there. So this is still working. But you can also add new signatures, and then you will be fine to go building your custom Mimikatz binary. Yeah, there's 1 or 2 more things that I wanted to do. I don't know how motivated you people still are. SandBox Evasion is one thing that's pretty fast to be done. Parent process, and I had one more. I should show you the repository for this one. Where's my browser? Did I close it? Check, please. I really like this repository for SandBox Evasion techniques, because it has support for so many different languages. It's C#, it's C, it's Go, it's Perl, PowerShell, Python. Don't know what this one here is. Ruby, Rust, and VBS. I added VBS via pull request 2 months ago. But this repository is really cool to get some basic SandBox Evasion checks before executing your actual payload. And one thing we can do here, usually it's pretty good to check for the domain if you know the target domain. So if you're building an implant, it's pretty good to check the domain. If you know it's, for example, company.local, then you can check for company.local, and only if the domain is company.local, then the payload will be executed here. That's pretty effective already for many organizations. In this case, the system is not domain joined, so I'm not going to use the domain check, but I can use, for example, dialog box in combination with disk size check. So we can check the disk size. If the disk size has a minimum of 50 gigabytes in this case, 50 gigabytes is pretty low. Maybe at the time of writing check please, this was okay. This disk is pretty small, but I think the most disks today will have at least 200 or 250 minimum disk size. So you can also make this value bigger. So, and this one here is the proceed. So we can say if proceed, then we also do dialog box, and we can say if the dialog box checks, then we can say download our malicious sample, for example. So test. So this could be, for example, 2 checks to say if the disk space is bigger than 75 gigabytes, in combination with if a user clicks on a dialog box, and only then this is executed. So the disk space is bigger than 75 gigabyte in this case. So the dialog box is opened, and if no one, or if SandBox normally doesn't click OK, so SandBox wouldn't do this, and it would run in a timeout, and the IEX download, the script, will never be executed at all. So this will be fine. We can just, for demo purposes, make a covenant connection here. First need a listener. First need a listener. So this is my IP address. We're creating a listener. We're using the default profile in this case. We're patching AMSI, so I think this is okay to use the default profile. Normally, I would modify the profile before using this, because all the things that are contained in the profile are flagged by nearly all vendors. So this is base64 encoded in the binary and is flagged. This is flagged. The user agent is flagged normally. IIS version is flagged, and this default thing here is flagged as well. But I think it's also not that much overhead to. Come, we're doing this. It's not much overhead. We can say we are VP admin username gleich equal work ID. This also is a modified version of Covenant. I also wrote a blog post on how to modify some C2 frameworks. This one. And the bash script that is in the very end of this blog post, this is the bash script I used to set up Covenant in this Kali instance. In this case, all the grunts were renamed to Otto, and in this case, all the grunts are renamed to worker. So it's, yeah, you can read the post on your own. We can say we choose a normal user agent here. We can also say we don't need a really good user agent here. We just want to evade signatures, so we can just say the user agent is user agent. And now this is a password because it's something like a WordPress login. And so we have a username, we have a password, we changed the signature. This is changed via my bash script. You have to change this as well. You can say edit. And then we have a new listener or new profile. For our listener, we can say create a launcher. We want to create a PowerShell launcher. 5.9, this is correct. We create a PowerShell launcher because This should be obvious. Script PS1. In this stream, the focus is on PowerShell, so we're creating a PowerShell launcher. Oh, copy paste doesn't work. I hate it. Nope. Nope, nope, nope. Copy, paste. Nope. Okay, we're doing like this. Worker app added HTTP1. Root downloads worker HTTP. Many workers. PS1, this is not the one. So this is our PowerShell script for our stager. Now we're building an AMSI bypass. We can use the one from here because it's working at this time. I expect to normally if this here would be a blog post, this bypass is flagged latest tomorrow. So I think this won't work maybe from tomorrow on. I don't know. I don't know if Microsoft is watching videos, but they obviously are looking for blog posts. Oopla. Local pawn drop. Pawn drop is always blocking this port. Nope. Still not. Then we're using port. Covenant is using this port. Sorry. My listener is already on port 80. Yeah, and they own GitHub. That's right. So they can do basically what they want. So the bypass, I have to do one more thing here. New object, net web client, download string. So we're first bypassing AMSI, and after bypassing AMSI, we're loading our second stage, which is the covenant worker. And it was called script PS1, and the port is 8000. So we are doing something like this. And maybe this should now work to give us a new worker. Let's just check this. Upsala. HTTP. This is the IP, port 8000, bypass PS1. Yep, this worked. So we bypassed AMSI with the first script. The first script was downloaded, bypass PS1. This patched AMSI in memory. Then the second script was loaded in the end of the bypass, and the second script actually gave us here a stager. So this one would load a covenant stager if the target system could reach this port here. So we can check this. If we execute this one now, the first check will proceed, and the second check with the dialog box if we don't press that dialog, then we won't get a new stager here, because yeah, it's only loaded after this message box being pressed OK. So if we press OK, we get our new connection coming in here. And just to check, or normally you can now use this here to for example, I would not recommend to upload anything to VirusTotal if you really have your command and control framework behind it, but just if you want to test this, VD test, and I also want to, so just for fun, but this normally cannot lead to detections, because even if the VirusTotal sandboxes don't click this button, or even if they click it, they would not load the bypass script here, because it's local. This should be obvious. So this is just for fun. But we could also, to make it a little bit more realistic, could also load Mimikatz afterwards, for example, to just check how effective these sandboxes are. Load Mimi load. So this is another test. I mean, this should in the sandbox result to, if they bypass the dialog box, this should result into executing Mimikatz. So this should lead to some detections at least. So and if they don't detect Mimikatz from being loaded because of these two sandbox checks, then I'm pretty sure that they also won't detect a command and control connection here. And just for fun, we can do one more thing. One more feature of ISE-Steroids, what I like is the possibility to create an executable from a PowerShell script. So we can say tools, turn code into executable, and we can say, yeah, the console should be kept open. We can add a custom icon. We can apply digital signature. If we have a certificate, we can apply a signature of, if we want, and some other things. We can change the copyright from, we can leave it at secure this shit, and we can just create an executable for fun. VirusTotal test. So now we have a VirusTotal test executable, and just to see, disk size is over 100 gigabytes. We will proceed. Dialog box. Clicked OK. Ah, okay. My fault. My fault. We need an AMSI bypass before. Okay. It's good to always test before using it. What is the PowerShell AMSI bypass I used here? This one. So we are first bypassing AMSI. Afterwards, we're loading Mimikatz, and we're executing Mimikatz. This is VD test. Replace it, yes. Because just to sum up everything we did so far, we again randomize these values. And now our PowerShell script looks like this, obfuscated via ISE-Steroids. We can say turn this code into an executable, add an icon, whatever you like, and say virus total test. Yes, I want to replace this one. Just to check if this works. Where's the dialog box? Here's the dialog box. This process should be killed by Defender because it should now execute Mimikatz actually, so via PowerShell. If you create an executable via ISE-Steroids, then this is a C# binary. It creates a C# binary, and this C# binary in the background calls the PowerShell executable with an encoded command. So all this here is encoded and is called via encoded command AMSI bypass true Mimikatz. And this process was killed. Okay, let's check if this is detected from some engine on VirusTotal. Oh, it's a dropper. So some of them can look at can do a static analysis. I think that these detections don't come from heuristics, but I think that this is a static analysis, and the static analysis will show that IEX, new object, new net web client download string is base64 encoded in this executable. So these will be signatures that I'm inhuman, yes. These are signatures that flag on this part here. If you further obfuscate this part, then I think, or if you don't build an executable via ISE-Steroids, because PowerShell with encoded command is not the best idea to be stealthy, because there are some AV vendors which already flag the use of encoded command. If you're using, for example, this with some base64, whatever, then already for this there are detections. It's not the best idea to do this. And the PowerShell Empire default stager, for example, is using the base64 encoded command. So I always change, if I use PowerShell Empire, I always change the encoded command to loading a clear text script, because encoded command itself is often cached. Yeah, that's a little bit for SandBox Evasion. We can do one more check because for fun, and we can check the script without SandBox Evasion to get a comparison. So we can do this AMSI patch, Mimikatz, and Mimikatz execution. Would already be more fun to actually really dump credentials. Sure, I could use invoke Mimikatz instead and then use credential dumping, but no, it's too late. So we're creating an executable. This test no sandbox. So let's see. Let's look at the difference. I think we're at 11 detections, right? So these two SandBox evasion checks just in single quotes, whatever, bypassed 7 vendors, and the others PE injection. PE injection is really correct. The only one with a correct description for what is happening. Or is there any Mimikatz? No, no Mimikatz. All others only tell this is malicious. Yeah, I think, at least from my side, this was the main content that I wanted to show today. Just look up my notes. But I think that there's the only things that didn't work were PSBypassCLM, and I don't know why, but AmsiTrigger didn't work, which is really strange from my point of view. I think I did a restart. But I think the usage of AmsiTrigger is really self-explanatory, and if you go through this blog post, then it's already explained how to use it. In this case, you can also specify an URL for your PowerShell script, and then it will show you the actual triggers in the script. And in this case, PowerUp, I tested it yesterday. PowerUp had one trigger, and this one trigger is really easy to change. But you can find the triggers via AmsiTrigger, and this is better, and it is faster than manually searching for it. So this tool provides you a way to automate the process of finding signatures for manual ThreadCheck. Yeah, ThreadCheck is has another approach. AmsiTrigger is written for PowerShell scripts, and it's but ThreadCheck also has an AMSI flag. Yeah, this was -e AMSI. We can test this. -e AMSI -f PowerShell power up. Okay. Could not load file or assembly command line. This is sucks. I think I have an exclusion for this folder. Normally this should not been flagged. Protection history. Protections of going through all these dialogues here is a pain, I think. See stream. I have to clean up the desktop afterwards. ThreadCheck does work on PowerShell scripts, yeah, but it's not written to be used for PowerShell script. It's written to be used for C# binaries, and it's checking the C# binaries for either the default signatures. So if you drop the binary on disk, it can be flagged and then it can be removed. And this is a default signature, but a C# binary can also get flagged by the anti-malware scan interface if you load it via assembly load. And you can, with ThreadCheck, you can do an AMSI scan, anti-malware scan interface scan, and you can, without the -e flag, you can check for signatures on disk. It's like it's pretty much the same with Defender check. I think Rustamos, I don't think it is like this. Rustamos took the code from here and he modified it to also include an AMSI scan. And in basic, the approach of Defender check is pretty simple. It splits the binary in chunks like AmsiTrigger does. And then there is an executable from Microsoft. Which is called something like mp-scan-exe, mp-cmd-run-exe. And then you can use mp-cmd-run-exe to scan a binary, and mp-cmd-run-exe will return either this binary is malicious or this binary is not malicious. And this is done for all the chunks of the binary to be scanned. And then you will see the bytes that are flagged from the binary. This is basically what Defender check does. And ThreadCheck does the same, but also includes, I think, the approach from AmsiTrigger to use or to include AMSI-DLL in the current process and to scan the binary via anti-malware scan interface itself. So AMSI initialize. No, this is not here. Scanning engine Defender AMSI. Take a look. AMSI. Scan with AMSI and that's scan with AMSI. Yeah, creates a new AMSI instance. Checks if real-time protection is enabled. If not, it will analyze. And this will be a separate binary, most likely, AMSI instance. So this will do the same. It will scan via AMSI, and if the result for each chunk is AMSI result detected, AMSI can return this, and if it returns this, then we know we found our trigger. So ThreadCheck is basically a combination from AmsiTrigger and Defender check. That's at least my understanding. Just try to compile a new one, and we're doing a little bit of C# obfuscation. I think it should not be that hard to build a ThreadCheck version which is not killed by Defender all the time. This should be pretty easy, I think, if no system management automation is needed here. In the normal case, we can just go here, say we want to replace. I used Control, Shift, and H to replace one word for the whole solution. Scanner. So we're replacing ThreadCheck with scanner for the whole solution. I hope that this is already enough to get a binary that is not flagged. Command line. Okay. Is this a nugget package? I can restore them. Yeah, I want to restore command line. Let's see if this worked. Yeah, this worked. Let's see if this is detected. Minus E AMSI minus F PowerShell power up. No thread found. This cannot be true. So I think this applies to C# binaries only, but not to PowerShell scripts. Couldn't find the trigger for power up, but power up definitely has a trigger here. Image settings, cloud protection. Yeah, this definitely has a detection. I'm going to do one more thing. I'm going to download AmsiTrigger now. I'm going to do the same, just to see the difference. I'm going to do the same which I did to ThreadCheck, and then we will see if AmsiTrigger also is not flagged anymore. But I think this is basically for the most C# projects. It's enough. Not for Rubius, not for Seatbelt, not for the big ones that are used by everyone, but for the most smaller C# projects which are published on GitHub, it's really easy to modify them so that they are not triggered anymore. So in this case, we're doing exactly the same. Control-Shift-H, we replace AmsiTrigger with scanner2, whatever. 9 occurrences. One more thing we can do just for fun is, for example, oh, this is not the thing I was searching for. Assembly info. Often AV vendors trigger for this GUID because it's not changed if someone else compiles the project, so you can basically also find a C# binary by this ID, and if you change the ID, then you're good to go. Not always, but this can be one more method. So AmsiTrigger bin release. MSBuild version, okay. So let's see if this works now. Power up, PowerShell, power up. This is really, Can it be? Check. Oh, real-time protection. Real-time protection is enabled if AMSI result not detected. So they are looking for AMSI scan buffer. If AMSI scan buffer is detected by AMSI, then you know what? We know that our real-time protection is enabled, so we just remove this check. Makes no sense. Now it doesn't return any result. I don't know why this doesn't work anymore. I tested it yesterday and it worked. I'm going to do one more reboot to check this again. Maybe this is also reboot related problem. Power up. Is this a normal version or is this an obfuscated version? This looks like a normal version. Can also check this from URL. Could not create a secure TLS SSL channel. Okay, this is a bug because I think that SSL TLS version 1.2 and 1.3 is not set for the web request. I could fix this now, but this is I don't want to fix this now. I'm just trying to restart one more time. Yep. See ya. So the stream is now going to be about 3 hours. So I think I'm doing this one more approach and then I'm going to finish for today. And next time we can then take a look at C#, and maybe the time afterwards I will take a look at VBS and NIM. Yeah, I already showed them most things. If no one has a question afterwards, I think I'm fine with the session for today then. So let's try this again one more time. Stream. PowerShell, power up. (4:55 p.m.) So I think this is yeah, it's triggering on. I want to allow this. I want to allow AMSI trigger. Yes. This is strange. I don't know why it doesn't detect the... Yesterday it did detect it. Can't tell you. Makes absolutely no sense for me. But yeah, I think I will finish for today. I will show this next time, and PSBypassCLM as well. So we went through Invoke-Obfuscation, ISE-Steroids, Pyfuscation. We went through PPID Spoofing. For in-memory scan evasion, we went through SandBox. We went through logging bypasses. We went through constrained language mode bypasses. I think it's pretty much for one session already. Yeah. Yeah, I hope that this was a help, or that I could help some of you to get a new or another approach for obfuscating or for bypassing antivirus in this case. But it's really not that complicated if you know how to find the signatures, and if you know how to obfuscate the tools, or which tools to use for obfuscation. And if you know how to build your own AMSI bypass, then you're fine to go for PowerShell. And if you one thing that I didn't show, this is now if you have a covenant session, here you can say PowerShell import, and you can import basically any script you want, and you can afterwards execute the PowerShell function with PowerShell. So this has our covenant has a PowerShell run space included, and if you import a script here, it will not get detected by script block logging because it's a separate PowerShell run space in C#, which doesn't make use of PowerShell exe. So you can use any script in this command and control framework without having to worry about script block logging and without having to worry about AMSI, at least if you patched AMSI before executing the stager. So basically, most of the time, I'm not using PowerShell exe to execute commands anywhere in any environment, but instead I'm connecting all the systems to Covenant or to another command and control framework, and I'm using all the PowerShell scripts inside of that because it bypasses all the protection mechanisms. So this is the way to go if you don't, or if you're going into, yeah, I would anyway recommend to use a command and control framework for every thing, even in a penetration test. I'm using a command and control framework for every system which I compromise in every penetration test, because it just saves so much time. And if your implant works, then you can do basically anything. You don't have to worry about anything anymore. Should so, but you already have the power. What? Could the C# binaries created via ISE be used in Covenant execute assembly? Yeah, but this makes no sense. If you the ISE-Steroids executable that is generated makes use of the native built-in Windows PowerShell. So you can use this, and you can use execute assembly or whatever to execute it, but in the background it will spawn a new PowerShell process, and it will execute the command which you had here in the script, which you made an executable from. It will execute this as an encoded command with the native PowerShell exe. So if constrained language mode is active, or if logging is active, then the command will still get logged even if you build an executable here. Yeah. So you can use this and you can do this, and I think it's nice for CDF, but I wouldn't use this, for example, to build an executable as a stager for red team engagement. This makes absolutely no sense because it's so loud compared to other techniques. A C# executable that opens up a PowerShell process with an encoded command, really, that's that's way too loud. I would not use this in any engagement where the goal is to stay silent. But you can use it to bypass AV. If the script is detected, you can still build an executable, and in many cases you can use this executable to execute the script. If you don't have time and you just want to make an executable, then this can be one way to go. Other questions? Yeah, I think I'm really not a Twitch expert, and I think that with the tool which I'm using here, I had the possibility to either stream or make a video. But yesterday I did read that I can just download the video from Twitch because it's saved for 14 days. So my idea was to download the video afterwards and to upload it on YouTube, whatever, so that you can go through that in a faster time or slower, or look something up, whatever you want to do with it. Yeah, then I think we're finished for today. And yeah, thank you for joining. And I think it was, for the first time, fun for me. So I think I will do more streams. It's good for my English, at least, to speak some from time to time in English. Bye bye.